hi guys, I'm Daniel David from STEM 1C. And I'm going to talk about limits of function. First, what is limits? Limits the value that a function or sequence approaches as the input or index approaches some value. So first, we have the easy limits. It's called easy limits because you're just going to substitute the value of x. So given the limit x approaches to 3 and 2x plus 5, you're just going to substitute the value of x to the side of 2. What are you going to do is you're going to change the value of x to 3, multiply it by 2, and add 5. It will be equal to 11. Because the value of 2 times 3 is 6 plus 5 equals 11. So we have limit of x approaches to 3 and 5 over x plus 3. We're just going to change the value of x to 3 and we're going to copy the remaining given. It will be equal to 5 over 6 since 3 plus 3 is 6, and copy the numerator 5. So now we have limit x approaches to 0 and sin x. We're just going to change the value of x to 0 and it will equal to sin 0. Same like before. Use a calculator to find the value of that and it will become 0. Side note, whenever you trig function in calculus, make sure you have your calculator in radians because all of calculus uses radians. Next we have form 0 over 0. So before we proceed, if you put 0 over 5, it will still equals to 0 and this is perfectly fine. But if you put 5 over 0, this will become undefined and it can't be equal to 0. So now we have limits x approaches to 4, x squared minus 16 over x minus 4. So sometimes people just tend to substitute the value of x, which will become 0 over 0, but that's not right. Instead of putting 0 over 0, we're going to use algebra to factor. So what are we going to do? We're going to copy the limit and we're going to factor out the numerator since it's a difference of square, and we can factor out the denominator because it's a 1-degree polynomial. And as we can see, we can already cancel x minus 4 and now we're left with x plus 4. So we'll copy the limit as x goes to 4 of x plus 4. So just substitute the value of x, which is 4 plus 4 will become 8. Another example, we have limit x approaches to 9, square root of x minus 3 over x minus 9. If you're just going to substitute the value of x, it will become square root of 9 minus 3 over 9 minus 9 equals 0 over 0. So we are going to use another technique called rationalizing. So we're just going to copy the given and put some bracket around it, and then over it I'm gonna multiply it by 1. Certainly that doesn't change anything when I multiply by 1, but it doesn't change but I'm gonna make it as fraction because anything divided by itself is 1, which I put square root of x plus 3 over square root of x plus 3. To make it clear, it will become like this one. So as you can see, I just copy everything, and right now you're going to multiply the top 4 terms right here, so like that, and then copy it. So it will become square root of x times square root of x is equals to x, and square root of x times 3 equals to negative 9, and then just copy the remaining items for the denominator. Cancel x minus 9. So we are left with square root of x plus 3. Substitute. It will become square root of 9. Square root of 9 equals 3 plus 3 will become 6. So here will become 1 over 6 since you still have 1 at the top because of your cancellation. Real life situation. Question: if I toss a coin n times, what is the probability Pn that I have not yet tossed a head? Now, what is the limit as n goes to infinity of Pn? Pn will be equal to 1/2 n squared. Then, limit as n approaches to infinity, Pn is equals to 0 because P equals to 1/2, 1/4, 1/8, 1/16 as n gets closer and closer to 0 as n gets infinity. And that's all. Thank you.